it's the same process. Okay, I'm just switching the code from whatever was doing to running interrupt handler code instead. Okay. When you're running interrupt handler code, okay, that code you can think of as kind of like high priority. Okay, it's treated, when you're doing this, it's treated as high priority. What do you mean by high priority? Meaning whatever it's doing typically, I don't want to say that. Let's see, what's the best way to start? When you're running interrupt handler code, you will not, okay, things that you must not do when you're running the code in the kernel, okay? You cannot block, and you can't call any function that will cause the code to block, okay? And also, inside the code, you also cannot call schedule. Okay? And I'll explain this in a little bit, okay? So what happens essentially is the interrupt handler goes off. You're going to be running some code in the interrupt handler. While you're running that code, you can't do these things, okay? Eventually you will sort of be done, okay? And then when you're done, you will go back to running, at some point you'll be done, right? And then you'll run some final, so kernel cleanup code, if you will, kernel code. What do I mean by kernel code? What are the kinds of things you're going to do there? You might say, do I have any signals pending, right? You're kind of like switching back to the process. Do I need to call schedule, right? All those kinds of things will happen here, okay? And then eventually you'll exit back to the user code, okay? But there's a point from when the interrupt handler starts until when it's done handling. In between here, you cannot call schedule, and you cannot block. So you can't call anything that blocks, okay? Yes? You can think of it that way, sure. A hardware initiated function. Okay. Yep. All right. So in that sense, when you're running in the interrupt context, that is, you're doing an interrupt handler, even though it is just some process doing interrupt code, it's a little bit special, okay? Because there's certain things you're not allowed to do in the kernel, okay? And why is this the case? So, for example, oftentimes when you are in interrupt handler code, one of the things the interrupt handler will do is it will disable interrupts, okay? Because you're in the interrupt handler code, it doesn't want to deal with other interrupts showing up at the same time. So for portions of the code, you'll disable the interrupts, okay? And you can imagine that if your interrupts are disabled, you probably don't want to be in the middle of your interrupts being disabled, call schedule, run something else, which then starts running some while one, which can never stop running that while one because interrupts are disabled, so nothing will stop it, right? So there's sort of like bad things that can happen, right? If while your interrupts while you're in this interrupt context, you do things that are okay in the normal case, okay, but not okay in the interrupt case. All right? Okay. So I just want to make sure that this interrupt thing is a little bit special. Okay? Yes? So, this is my CPU, okay? And this is my check interrupt flag, okay? And then this goes to, a bunch of hardware that goes to your, keyboard, goes to your, mouse, goes to your network, whatever, right? All these things coming in. And suppose, let's go away from, you're typing really fast, but instead I've got a 10 gigabit, Ethernet coming in, I'm shooting packets really fast, right? What happens, right? Do these things come up? Interrupt, right? And the first approximation answer is, the simplified answer is, yeah, you get the interrupt here, but what disable interrupts means is CPU then isn't going to check that. So you execute the disable interrupt instruction, and the CPU is, okay, well, while this interrupts are disabled, I'm not going to check if they're in. Right? No check, no check, no check, no check. Enable, not check. Right? So when you check it and say, oh, okay, this flag is set, let me go and see, what happened. Right? Now, typically, right, when you send packets, right, why is the interrupt important? The interrupt is important because you want to say, or the keyboard, why is it important? Because you want to tell the CPU, hey, there's something here, there's something on my hardware you need to take care of, right? So it's really just a notification. But you don't really need a notification for every single packet, right, necessarily, right? You just need to be notified there's something to go take care of, and then, the hardware should go, okay, well, what do I need to take care of? Oh, yeah, I see I've got a lot of packets to take care of, right? And then it can go and process the packets. So it's not necessary to get one for every single. So will you lose interrupts? I mean, you might not process as many interrupts, right, in some sense, right? But hopefully it's designed so that you get all the information you need. Now, is it possible that you can lose stuff because you've disabled interrupts for too long? And the answer is absolutely. For example, okay, I'm sending packets, right? I'm sending data. Somebody's sending data to your computer, right? Well, that data needs to go somewhere, right? Typically, it'll go to some area of memory, for example, right? It might go to some temporary buffer on the network card, right? And then it sends an interrupt saying, hey, I've got some data out here, please take it out of my buffer and put it someplace that's supposed to go, right? That buffer is a finite space, right? It's a limited size, right? So if you ignore it for long enough, then the buffer fills up, and then what happens to the data coming in? It's got no place to go. It's dropped on the floor, right? So in that case, you could lose data in that case, right? So, but generally speaking, right, so long as you don't disable interrupts too long, you're okay. And that's partly why disabling interrupts is a kernel, is a privileged instruction, right? You don't want people to disable interrupts very long. This interrupt code, when you write an interrupt handler, right, you want this to be relatively short and fast, right? Because you are like saying, okay, normal things I can't do now, right? So you do want to make sure your interrupt codes are tight, are small, right? So you don't disable interrupts for too long, right? Okay. Now, it is possible, okay, for an interrupt handler to disable interrupts for some portion of it, but not the entire thing, okay? And why might that be the case? Well, for example, one of the things the interrupt handler has to do, right, when it starts running, is it's going to start running on the CPU, right? It somehow eventually needs to go back to here, right? So it needs to remember how to go back to there, right? So one of the first things the interrupt handler will do is, okay, well, the hardware went off, right? It's going to jump somewhere else. As part of jumping this handler, the program counter is saved in some register. I'm going to, there's some other state that's in registers. I need to save all that somewhere, right, on my kernel stack. I'm going to save all that information so I can later on, I can come back, right? But you definitely don't want to be in the middle of saving where you were, and then all of a sudden another interrupt goes off, right? You're like not really fully saved yet, and another interrupt goes off, like you get in this weird state, right? So there's certain portions where you definitely need the interrupts disabled, right? And then once you've sort of gotten past that point, sort of gotten to like some stable state for dealing with interrupts, you could, in your kernel, sort of re-enable interrupts to handle other interrupts. Okay? So, in Linux, therefore, it is possible that your, and Linux does some of this, right? So it is possible that you're in some process, right? And then you give some interrupt, and here's some interrupt code, okay? And then as part of that, you